Alright, so we just talked a little bit about adding and subtracting in scalar multiplication of matrices, and now we're going to get into actually multiplying two matrices together. So this gets a little bit more complicated, which is why I'm putting this in a separate video. What I'd like to do here is show you a couple of examples, and then I might show you how to do this on a calculator as well if I have enough time on this video. If not, I'll make one extra one. Because it is really easy to do this on a calculator, so you can check your answers there. So I'll make sure I get to show you guys how to do that as well. So first and foremost, call this multiplying matrices. Let's go ahead and jump straight into an example here. If you look in the book, which is section 11.4, it does have some good examples of this, although there's a bunch of I would just say extra stuff that makes this sound a little bit more complicated than it really is, and I don't want to confuse you guys. So let's go ahead and let's come up with two matrices, and then we'll jump into the multiplying. So for matrix A, we'll go 2, 4, -1, 5, 8, 0. And for matrix B, it's going to be a bigger matrix. It's going to be 2, 5, 1, 4. 4, 8, 0, 6, and -3, -3, +1, -2, and -1. Okay, not sure why that became green. Alright, so first things first, when it comes to multiplying matrices, you need to make sure you write down the dimensions of the matrices. So the first one, has 2 rows and 3 columns. Okay, matrix B has 3 rows and 4 columns. Right. Now, in order to multiply matrices, when you write down these dimensions side by side, the second number, the number of columns in the first matrix, and the first number, the number of rows in the second matrix, has to be the same. Okay, if these two numbers are not the same, then it's going to be an undefined matrix. Okay, but in this case, they are the same. So when we multiply these, we are going to get a defined matrix so long as we do A times B. Okay. Now, whatever we have on the outside, the number of rows in the first matrix and the number of columns in the second matrix, that's going to tell us the dimensions of the matrix when we do A times B. So I know when we multiply A times B, and I'll show you how to do that in just a second, we're going to have a 2x4 matrix when we're done. Okay. So again, in order to multiply these inside numbers need to match, and if they do, then the numbers on the outside tell us what the dimensions of the new matrix are going to be when we're done. Okay, so let me go ahead and let's jump right into it. So what you'll see here is that A times B is not the same thing as B times A, so it does matter the order that we do this in. We're going to start out here with A times B. Now, this is going to look, again, really complicated. There's going to be a bunch of math involved here. But here's the deal. When you do this, you multiply across the row in the first matrix, and you multiply down the column in the second matrix, and you're adding all of that stuff together. So let me show you how this works. Okay, here's what we're going to do. First things first. For our first entry in our new matrix right here, we're going to go across the first row and down the first column. So here's what it's going to look like. 2 times 2 plus 4 times 4 plus -1 times -3. Okay, so there's going to be our first entry. Alright, I'm not 100% sure if I'm going to have enough space. I'll try and do this all in different colors so we can keep it all separate. Okay, alright, next entry. We're going to go across the first column again, and then we're going to go, across the first row, and then we're going to go down the second column. So this is going to be 2 times 5 plus 4 times 8 plus -1 times 1. Okay. Third column here, and I probably am going to run out of space. Let me go ahead and shrink this down so I can keep it all. Oops. So I can keep it all here. I'm going to make sure I get it all on the page in the right direction. Okay, we're going to go again across the first row. This time we're going to go down the third column, so it's going to be 2 times 1, okay, plus 4 times 0, okay, plus negative 1 times negative 2. Alright. Again, shrink this down a little bit. I want to make sure we can get it all on here. Okay. Oops. Sorry. Alright, and then for our fourth column here, we're going to do the same thing. Our fourth column, or our fourth entry in the first row of our new matrix. Again, we're going to go across the row and down the fourth column. So we're going to have 2 times 4 plus 4 times 6, okay, plus negative 1 times negative 1. Okay. And that would be the first row of our new matrix right here. Alright. Shrink this down a little bit. Let's see. Okay. So we have, again, we went across the row, okay, across the row in this first matrix, and then down the column of each of the columns of the second matrix, okay. And then for our next matrix, we're going to do, for our next row in our multiplication, or in our product matrix, we're going to do the same thing, but this time we're going to go across the second row of the first matrix and down each column just like we did the first time. So when we're done here, as we go across the first one here, it's going to be 5 times 2 plus 8 times 4 plus 0 times negative 3. Okay, and what you'll see here, just a couple little patterns. All of the first numbers and the second numbers and the third numbers are going to match for everything in the first row. Okay, and then if you're looking down the columns, all of these second numbers are going to match each time. Okay, so there's like some patterns here that you can see as we're going across. Alright, so now let's go to our second entry. It's going to be the second row times the second column here, so it's going to be 5 times 5, okay, plus 8 times 1. Let's see, I'm sorry. Let me make sure, yeah, 5. Let's make sure that these numbers are matching up here. Plus, I'm sorry, 5 times 5 plus 8 times 8. Okay, plus 0 times 1. Alright. Again, these are matching 5 and 5, 8 and 8, 1 and 1. Alright, so that's looking pretty good. Alright, next one, we're going to go second row times third column. So, shrink this down some. Alright, so next time we're going to go second row, third column, so we're going to have 5 times 1, okay, plus 8 times 0, okay, plus 0 times negative 2, okay, again, these are matching, 1 and 1, 0, 0, negative 2, negative 2, and last but not least, we'll go second row times the fourth column, so we'll have 5 times 4, okay, plus 8 times 6, okay, plus 0 times negative 1 right here, alright, and again, 4, 4, 6, 6, negative 1, negative 1. Alright, and now the last little bit, the last little bit that we need to do here is we need to do the math for adding these together. Alright, so I'm going to show this in 2 steps. So if we go through and we do this, 2 times 2 is 4, 4 times 4 is 16, negative 1 times negative 3 is 3. Okay, so there's going to be my first entry. 2 times, let's see, what is that? 2 times 5, so that's going to be, I'll do this in different colors. We'll go 10. 4 times 8 is 32. Negative 1 times 1 is, that's going to be minus 1. Okay. 2 times 1 is 2. 4 times 0 is 0. Negative 1 times negative 2 is 2. 2 times 4 is 8. 4 times 6 is 24. And negative 1 times negative 1 is 1. Okay, so there is my complete first row of my product matrix. Okay, over here we've got 5 times 2 is 10, plus 32, plus plus 0. Okay, we've got 25 plus 64 plus 0. Okay, right here we've got 5 plus 0 plus 0. And then on this last one we've got 20 plus 48. 0 plus -1 is 0, and then last but not least we just need to add these together. So we're doing our final little bit of math. That's 20 plus 3, so we've got 23. This would be 42 minus 1 is 41. 2 plus 0 plus 2 is 4. 8 plus 24 plus 1 is 33. 10 plus 32 plus 0, that's 42. 25 plus 64 plus 0 is 89. 5 plus 0 plus 0 is 5. And 20 plus 48 is 68. Okay, so there would be my final matrix, multiplication matrix when I am done. Alright, so that's how we go through and we multiply these matrices. I will go through and show you one more, although I'm going to do that in another video, and then real quickly I'll show you how to do this on a calculator as well. Okay, general idea again is you go across the top, across the rows in the first matrix that you in your multiplication, and down the columns of the second matrix, and we're adding all those values together. Okay, and general idea again, the inside numbers on the dimensions need to match, and if they do, you can multiply them. If they don't, it's undefined. If they do match, then the numbers on the outside, in other words, the number of rows in the first matrix and the number of columns in the second matrix, that's going to give you the dimensions of the matrix when you are done. Okay?